Hello everyone and welcome to MECO Rocket Simulator. This is a program that's sort of a game, but I'm not really relying too much on the gamey aspect of it. And it is available on Steam. It's in early access and it's currently on sale. It is by a solo indie dev, Danny Sim. The official title of the dev is Lauren Aerospace Limited though. And well, it's complicated. It allows you to simulate rocket engines. As you can see, this is just the beginning of it. This is exactly how it is when you get into the program. And it says that this is the Vulcan engine model, and that's the Ariane first stage engine. So, and this person does not want me to press the play button, which is being pointed at right there. So obviously we have to. But it does feature anime characters, people, and I think AI generated anime characters, and also AI voices, as far as I can tell. One thing was that I turned off the music. I would really appreciate it if we could just turn down the music instead of just go off and on. And it's sort of weird that the music is... I guess these are the pieces. But yeah, it gets a little bit loud, and so I can't have it on, unfortunately. So, that being said, let's see what happens, right? We must press this. In fact, it says, ignore me if you want. I'm not your manager, so let's ignore her. Okay, so it does all this stuff. And we see... Okay, so that completes the mission, and it has 423.7 seconds of ISP, 996.8 kilonewtons of thrust, it says here. So we would like to see this kind of simulation of our own engines, of course. This is very impressive, if it's correct and all, and we can hope that. But anyway, don't press run test, complete mission. Don't touch that, yeah. I might want to turn off the sound effects too. Only because of the volume of it. Models are built from components wired into a graph. Run test requires a simulation. You'll build your first model from scratch in the next mission. Okay.
Welcome to MECO. I'm MECO, your fellow
loud.
propulsion systems engineer. Our software is a little challenging at first, but don't worry. I'm here to help you every step of the way.
Okay, can I turn off her voice too? Maybe that's under sound effects. I can read, it's fine. Honest. So there's a mission mode and engineering mode. We can just free build as engineering mode. Remember that this is early access and there's just one person on the dev team, so it could take a while to improve this. Okay, I want to see whether turning off the sound effects means that I can avoid her voice. Yes, it seems that way. Or maybe there was no more voice after that point. I don't know. When you select an objective, its instructions appear here. The mission panel stays docked to the right, so the workspace remains clear while your next steps remain visible. You can return to the mission brief at any time. Okay, and then it's pointing here. Well, it's just saying that that exists, I think. Head to the models page, your digital workbench. Click on that, go to models, add model, and okay, create a new blank model. Well, let's do that. Okay, and let's call it ED1. Traditional. Okay, it wants in my first model specifically. Okay, fine. Learn fundamentals of liquid flow networks. Okay, nice first steps. Okay. Now we'll build a tiny liquid network. 2 nodes, 1 branch. Clean topology, clear signal. Whatever that means. That sounds AI written too. We will start with a 2-node single branch liquid flow network to build intuition. Nodes are points in your network where fluid has a temperature and pressure, like fittings in a plumbing system. Yeah, it's plumbing. Yeah, we're doing plumbing. All right, fine. Model load, navigate, model, locate my first model, click to load. Okay. Okay, add a node inlet. Okay, we have our first node. Okay, now we have to, it's my boundary condition and lock source. Okay, how do we configure it? Click on it, choose edit, inlet, liquid, oxygen. So right now it's got methane, hydrogen, nitrogen, oxygen, and RP1. I didn't think RP1 was refined petroleum, was it? I genuinely thought it was rocket propellant one. Oh, I guess both ways of reading it work. So it can be rocket propellant one or refined petroleum one. Interesting. I only knew rocket propellant one. All right. I've learned something. Okay. So, fine, I've configured for liquid oxygen. Select node. Okay, well, I better keep going here. Now we add a node outlet. Add a branch between the nodes. Well, node can only connect to one branch. Okay, well, I assume the LJ goes here somehow. Okay, well, let's see what it has to say. Pipe, yeah. Locks at this pressure. Your outlet node says the same for the other end. Maybe you have to add a branch. Oh, I have to add a branch component. Okay, a branch component is another component, so we have to hook it up like this. Okay, now we've got a branch component. I thought I could just draw it. Okay, then we have to configure the branch properties. So we have a length. Oh, we better type it in. Oh, we'll come back. Cross section, circle. Radius 1. Okay, I better not press enter apparently. Passage roughness. Well, we can have elbows and stuff like that. That doesn't really show the engine, does it? I mean, that would be quite impressive if it did. Okay, passage roughness. Well, we have to do 0.5. Okay, well now we can go okay. Right. Control parameters to set boundary conditions driving flow through your network. Add a control parameter component. It's near the bottom of the add component drawer. Okay, edit it. And we want pressure. And set it to 3 bar. Okay, then we're gonna connect this to that. That worked. I didn't need a branch for that. Okay, and then we have another one. Then we'll be connecting it to that. And it already knows pressure because I've connected it. So we don't have to necessarily type it in or add that parameter. Once it's connected to a pressure thing, it should know. But we want 1 bar there. So that's atmospheric pressure there. Add a mass flow rate chart for monitoring. So m dot. Click the branch component and add variable to new chart mass flow rate like this. Okay, so then we get a chart. Oh, we click this. Max time 1 second. Let's see, what is it? Okay, well, we keep it to 1 second initially. Okay, so then it runs for 1 second, and then we see that it's doing 8.44 kilograms per second. And that's probably because of the volume here, and the combination of the pressure and the cross-sectional area here. I know it's not asking me to do this, but let me just pump this up a bit. It says stop. Okay, well, let's reset. Aha, yeah. So by increasing the cross-sectional area of the pipe, we now have 50 kilograms per second. Or we could increase the pressure, and then we get 200, nearly 200, 197. So there we go, we can do that. We better reset the stuff so that it doesn't get confused. Okay, well, I've played around with stuff. Let's go. Alright, so we've got that kind of thing. Cold gas reality check. Alright, cold gas thrusters. So the astronaut MMUs used nitrogen cold gas thrusters, and then SpaceX had used them for a bit. And same building blocks as before. Targets. Thrust is greater than 65 newtons. The mass flow rate is 0.09 kilograms per second. ISP is going to be 77 seconds or greater. Inlet temp 326 Kelvin. And first condensate temperature is less than exit temperature. That one I don't know about, but okay, I get that. So fine, let's models, create a blank model. And do we have to name it anything in particular? I think we can just call it cold gas thruster. Okay. So add the node gas inlet as opposed to liquid inlet. Okay, and we set it to gas nitrogen, that one. That's our only nitrogen option. And then a control parameter. This time we're oxidizer fuel ratio, it wants us to set to 10, which is weird because it's basically, I mean, it's a mod repellent. So why does it even have an oxidizer fuel mass ratio? So that's the first suspicious thing that I've got. Okay, and it wants it on the ratio one. Why would we do that? It's curious. I would expect the pressure. We should probably have a pressure one, but right now it wants a node outlet. And then it probably wants... Oh, no. Now it wants node gas internal between. So it used to be branch. Now we want node gas internal. Last mission, nodes only sat at the edges. Here, a node lives between two branches. The throat branch and the expansion branch, where flow transitions from converging to diverging. Wouldn't that be at the throat? Uh-oh, this seems more complicated. What is this trying to tell me? I guess it's trying to tell me J is upstream, I is downstream, so this is... Well, we can't connect it like that. So we need branches between each of these. And they have to be branch gas. And it wants this to be throat branch. And length 2. Radius 0.5. Throat radius is your mass flow governor. Well, I sort of already toyed with that last time. On this build, it's pre-sized. You'll mostly leave it at 0.5 centimeters and tune the expansion side instead. Okay, so expansion branch, I was expecting that. Oh, well, was I supposed to have a different outlet? No, node outlet is node outlet. There's no node gas outlet. A rectangular cross-section is interesting. Wonder why you would even have that. Set boundary pressures with control parameters. Okay, well, we've already got all the connections. Condensation is the gas turning into tiny droplets. Push the expansion too far and it gets so cold that the mist forms, stealing energy and slowing the exhaust. Okay. Add a control parameter. And that's for the gas inlet. Did it get that message? Yeah. So there's 5 bar. Initially, it doesn't have the parameter set, but then if I connect, it does. Set the value to 1 Pascal because we're a little vacuum thruster. Okay, then we have to add a chart. So here, add variable to new chart, and it wants stagnation temperature. And then here, it wants mass flow rate. And here, thrust compute nozzle thrust, so that's that. Maybe, okay, it does want these all on chart 1, except for the thrust. So we want 2 seconds, 2 seconds. Let's see. Well, we have 60 newtons. I forget what our requirements were. Okay, it does tell us. We want 65 newtons. And this graph is no good because the scaling is all over the place. Can we just break these into different things? Oh, it automatically went back to the earlier thing because I have not fulfilled that now. I unfulfilled that, so that's interesting. Okay, I want stagnation temperature there, but I want a new chart. Oh, here. There we go, chart 2. Hopefully it's okay with that, let's see. Okay, it's okay with me having it on chart 2. Still doesn't seem to have... Well, okay, they're just flat at that number, okay. So we've got too low a mass flow rate. We don't really have something show. Oh, the ISP's right there. Okay, too low in ISP. Well, expansion branch step the radius up in 0.2 centimeter increments to increase the mass flow rate. I guess we don't get to... Yeah, we don't get to increase the pressure. And we're gonna increase the expansion ratio in order to change the thrust in ISP. Okay, well, we're gonna need a few more. Let's say 2. Better, but not quite there. If the flow exit temperature drops below the first condensate temperature, then that is no good. So we have to watch these temperatures. So yeah, the flow exit temperature is getting down, but not low enough. But we still need a little bit more thrust in ISP. We're just 0.2 shy on ISP. Okay, there we go. We've got the 65 newtons, 77 seconds of ISP, and our flow exit temperature is just above the first condensate temperature. So obviously they set the requirements such that we would just barely be able to do it here. Okay, complete mission. Valve ventures. So next we will learn about valves, but I'll leave it here for this video. That's the first taste of MECO Rocket Simulator. And next time we will look at valves. And then at some point I am going to do a video just trying to design mine, but I better learn all the little functions first, and then we'll figure it out. I mean, at least it lets you run it without putting the valves in. That's nice of it. Presumably some of that, well, I mean, cold gas thrusters, did it really need a valve? Maybe not. I mean, it should need a valve, right, at some point. But anyway, the fewer valves, the better. We've learned this. Okay, but anyway, we'll set that aside for now. Engineering mode awaits once I go through all the missions. And not all the missions have been implemented. That's part of the early access thing. They have more missions planned than it currently has. So we know that, but I should learn as much as it has implemented. But for now, I think that's good enough first taste. So with that, thank you for watching. Hope you enjoyed this video. If you did, please do press like. If you have any comments or suggestions, please leave them in the comment section below. And I'll see you next time.